Hello. As you may recall, last time we were looking at the binomial distribution and we looked at this particular example, so I'm just going to very quickly run over this again just so that you understand what the binomial distribution is working out, what all of the notation means and so on, and then I want to have a look at some examples where it might be a little bit more time consuming than this and how we can use our calculator to make our lives a little bit easier. So the first thing here is we're given information about a binomial distribution. So we're told that the random variable x is binomially distributed with 10 trials and a probability of success of 0.92. Now the random variable x in this example was the success rate of a drug and how many people it cures. So x represented how many people cured, and this is the probability that x is greater than or equal to 8. So the probability that more than 8 people were cured by this particular drug with a 92% success rate, or probability of successfully curing somebody of 0.92. So we considered what that would be. Probability that x is greater than or equal to 8. Well, that's going to be probability that x equals 8, x equals 9, and x equals 10, because I've got 10 trials. So 8, 9, and 10 are the three situations that I would like to have a look at, and I'm going to add those individual probabilities together. So we did this manually. So we found the probability that x equals 8, and we can do that for any of these using this same structure. Number of trials, choose the number of successes. So here 10 choose 8. Here for 9 successes it's 10 choose 9. And for 10 successes here we've got 10 choose 10. Now these are just the numbers from Pascal's triangle. So from the 10th row of Pascal's triangle we're choosing the 8th number, the 9th number, the 10th number. But this C here, this combinations that we looked at in a previous video, all of that can be done quite nicely on your calculator. So this first part here is finding the number from Pascal's triangle to use for your combinations, and then the second is the probability of success. So here I've got 0.92 and then to the power of the number of successes, so 0.92 to the power of 9, 0.92 to the power of 10, and so on. The second part of the structure is the probability of failure. So I've got the probability of failure to the power of the number of failures. So if I've got 10 trials, 8 successes, 2 of those are failures. So probability of success, number of successes, probability of failure, number of failures. Working all that out, you get a probability for each. We wanted greater than or equal to 8, so we added 8, 9, and 10 together. So I've got my 3 probabilities there that we added together. So we found our probability here was 0.9599 to 4 significant figures. Now, that seems okay if you're doing something like this, and maybe this is around about the limit of what I would want to do in terms of doing it manually. What we're going to look at today is using your calculator to have a go at working some of these binomial functions out. Now, unfortunately, I don't have one of the white Classwiz calculators here at home. I know you guys have got those at home, but I don't have one. I've only got my my big fancy calculator, and unfortunately, you know, if I put this on the screen, it's all fine and well, but my screen here is going to look different to what your screen looks like. So I've drawn a picture of your screen. I'm going to explain how to get there, and I'm going to explain what all of that means. I'm also going to link a video on how to use this particular function in the calculator, so the binomial cumulative distribution. On the in the description, so there'll be a link to another YouTube video in the description to help you should you struggle with my description of how to get there and how to use this. So what you want to do, you want to put yourself into the binomial cumulative distribution function part of the calculator. So what you're going to do is you're going to click on menu. Menu is right at the top, second button in from the right, just underneath the screen. And once you're in there, you want to go into statistics mode. So you can either go and find statistics mode. The picture is like a little graph like that, something like that. It's number 7, so you can just push the number 7. It'll take you into that. And then if you push the down key to go into the second set of menus, because the first set of menus has got normal PD, normal CD, and binomial PD on. You want binomial CD, which is on the second page. So if you push the down button on your calculator, that'll take you into the second list on that menu. And then you want to click on binomial CD. So once you've found binomial CD and you click on that, you're given an option of either list, which is number 1, or variable, which is number 2. So you can either push the number 2, or you can move your selection down and click equals over the variable option. So once you're in there, it gives you this screen here. So your screen should look like this. I've drawn mine, but you should have that picture on your calculator. It should say binomial CD at the top. You should have X, you should have N, and you should have P. Now I'm going to explain a little bit about what all of this is. So CD stands for cumulative distribution function. Now, what it is that we're doing here when we're working things like this out, so we're going to look at this one in a moment, the probability that x is less than or equal to 5, given this binomial distribution function. Cumulative distribution. Cumulative here means adding things together, and that's what we're doing. If you recall the example that we just looked at and reminded ourselves from last time, we were adding probabilities together. So we were working out lots of individual probabilities and adding them together. Now this is just a function on the calculator that allows us to do that without having to work them out individually ourselves. The calculator will work them out and add those values together for us. So what we're going to do here is, if you look at this first question, probability that x is less than or equal to 5, given x is binomially distributed, number of trials is 12, probability of success is 0.7. Notice here we've got no context. It's not about drugs trials or anything. We're just given the key information here in this statement, and then we're asked to work out a probability. That's it. There's no context here. This is purely practicing your use of the calculator, and we're going to fold that in with a bit more context and things, and how to recognize a binomial distribution in a question and so on, a future video. So here it wants a probability that x is less than or equal to 5, so we need to work out 5, 4, 3, 2, 1 and 0. So that's 6 probabilities that we would need to work out manually. Now that's not impossible. I'm fairly sure that if I asked you to do it, you could do it, and to be fair, if we were in class I would probably ask you to do this first as your starter task, and then you'd all complain at me that it was a pain and you didn't like doing it that way, etc. And I'd say, well, actually there's a function on the calculator that allows us to be able to do this without. Now if you want to, for completeness, to make sure that your answers match and you can convince yourself that this does work, then please do work out the probability of 5, 4, 3, 2, 1 and 0 and add all those individual probabilities together. I would do it personally because I think it's good practice of the previous methods, just to make sure that you remember how to structure your individual probability that x equals 5, probability that x equals 4, and so on. So back to this. What we're going to do is we're going to type some things in here. So there's two of these things that are pieces of information that come from this statement here. So we are told that the number of trials here is 12. So the number of trials being 12 goes in here. So where it says n, if you move your cursor down so that the selection is over n and you change that to 12, so type that in as a 12 here, then it changes the number of trials from 0 to 12, push equals, and it'll punch that in there. The next one, the p, as you can probably guess, that is the probability, so that is this one here. So p is my probability, so I want to put 0.7 in there, like that. Now, the only thing that's left here is the x. Now, the x is telling the calculator what your upper limit is. Now, I'll show you what my calculator looks like in a moment. I'll do it now, actually. So my calculator has got, it asks for the number of trials, that's your n, probability p, but then it's got like upper and lower. So I can set a bound for the top, my upper bound, and I can set a lower bound. So of course the graphical calculator is a little bit more advanced, and if that's something that you're sort of thinking about getting into, you'll notice that actually you've got a few more functions on here, as well as just being able to plot graphs and things. You can do a little bit more with your statistics. It's a little bit easier to manipulate. This one, however, the white Classwiz that you've got in class, will only work out the following. It will only work out the probability that x is less than or equal to little x. Now little x is whatever value you put in here, so if I put 5 in there, it's going to work out the probability that x is less than or equal to 5. Now that works for this first question, sorted, but if I want to work something out like this second question where x is greater than or equal to 3, then we're going to need to do some thinking about what the distribution looks like, and be clever about it. So let's work out this one. We can just simply type 5 into here, and then what it's going to do is it's going to work out the probability that x is less than or equal to 5. So this will always work out less than or equal to, and the or equal to there for a binomial distribution is incredibly important that we remember that this value that you type in there is included. So here I want probability that x is less than or equal to 5, so that means the 5 is included. So when I type 5 in there, it matches, it wants less than or equal to, sorted. So if I do that, I'm just going to do it on mine, so I'm going to put 0 in, my upper limit of 5, my number of trials is 12, and my probability is 0.7. When I do that, I get a probability x is less than or equal to 5 of 0.0386, and that's the 4 significant figures. Now what I would suggest you doing is making sure that you try that and check that you do get that answer by using this, by typing 5, 12 and 0.7 into your binomial CD function on the Classwiz calculator. Right, on to the second question. So if you wanted to pause the video there just to make sure that you can check that you've got that, that's fine. We're going to shift on to the second question now. So that second question, I'm going to draw myself another little diagram here. So let me show you what it is. So this is binomial CD, binomial CD. You've got X, you've got N, and you've got P. I'm going to type these three things in. So you want X is greater than or equal to 3. So what we've got to start thinking is about how probability distributions work and what it is that we're trying to work out. So what I'm going to do is I'm actually just going to draw myself a couple of bars. So I'm just going to draw myself a little line. I'm going to draw the bar 3. I'm going to draw the bar 4 next to it. The bar 2 next to that. Now it doesn't matter how tall my bars are, if they're all the same size or whatever. I'm not particularly interested in it. I'm really just interested in which bars I want and which ones I don't. So here it wants greater than or equal to 3. So or equal to means I'm including bar 3. So bar 3 I want to know. I want to know what the probability that x equals 3 is. That each of these bars represents the individual probability. Probability of x equals 2, probability of x equals 3, and so on. If I want greater than or equal to 3, I'm going to want 4. And I'm going to want 5 and 6 and so on. So I'm going to want all of the bars from 3 onwards. That tells me that I don't want bar 2, I don't want bar 1, and I don't want bar 0. So thinking of things that we know about probability distribution functions is all of these bars, all of those individual probabilities must add up to 1. And we used that fact when we were looking at other discrete probability distribution functions in previous weeks. Here, we're going to use that fact in order to be able to work out the probability x is greater than or equal to 3. So if I want the probabilities of the bars that are 3 and onwards, what I want to do is I want to take 1 and subtract from that the probability of the bars that I don't want. So that's 2, 1 and 0. So that's the probability that x is less than or equal to 2. So I don't want bar 2, 1 and 0, so that's bar 2, 1 and 0 here. So I'm going to take those probabilities away from 1, and what it will leave me with is the probability of all of the bars to the right, so the probability of bar 3, 4, 5 and so on all the way up to bar 10 all added together. So in order to do that we need to work this quantity out. Now remember, the reason that we've done it like this is because the calculator can't work out greater than or equal to 3. The standard Classwiz calculator will only work out less than or equal to. So there are some things here that we can fill out from the statement about the distribution. So number of trials is 10 and probability is 0.6. So those two things can go in quite nicely there. This x here, you need to, if you just put 3 in, it's just going to work out the probability that x is less than or equal to 3, and that's not what you want. We're going to put 2 in here to work that probability out, probability that x is less than or equal to 2, and then I can take that away from 1, and then that will work out the probability that x is greater than or equal to 3. So 1 minus, now let me just work this one out. So 2 is my upper limit, number of trials is 10, probability of success is 0.6. So I get 0.122945. Again, check on your calculator to make sure you do get that. So I'm just going to take that away from 1 now. So I get 0.9877, and that's to 4 significant figures. So this here is the probability that x is greater than or equal to 3. Now, the examiner can make this slightly more complicated by asking you about probability of x lying between a pair of values. So here again, I'm going to draw a couple of diagrams for you. So I'm going to draw this here, I'm going to draw it twice. Shuffle it up a bit so that we can see. There we go. So we've got binomial CD, x or n or p, binomial CD, x, n, p, and then we have our bars. So I'm just going to draw my bars here. Now we're going from bar 5 up to bar 9, so I'm going to start at bar 4 because that's one below it, and then I'm going to do 5, 6, 7, 8, 9, I'm going to draw 10. Now I know what you're thinking, sir, I don't like diagrams, I don't want to draw a diagram, and I understand that. It's it's the common complaint of most math students that I've ever taught, that they hate drawing diagrams, they don't like drawing diagrams. It's one of the reasons why they don't like statistics, because all it is graphs and rubbish like that. However, drawing a diagram is the absolute best start to any kind of solution. Yes, it's good to be able to get to a point of being able to complete questions and solve problems using numerical and algebraic methods, but if you can see a diagram and you can do this visually, you absolutely should. Right, so looking at this here, I want to colour in the bars that I'm interested in. So I'm interested in not 5 because it's not included, so I'm interested in x being bigger than 5, so that means that 6 must be included, 7's included, 8's included, less than or equal to 9, so 9's included, 10 is not. So these are the ones that I want. So what we need to do is we need to use our calculator to work some things out. What I'm going to work out first is I'm going to work out what 9 and below would be. So the first thing I'm going to work out is the probability that x is less than or equal to 9. So into your calculator you're going to put my value of x is 9 because that's my upper limit. My number of trials here is 15, and we've got that from the statement about the distribution. And the probability of success is 0.45 because again that has come from our statement about the distribution. Now we can work that out. I'm just going to do that for you now. So upper limit is 9, number of trials is 15, 0.45. I get 0.923071128. Now that's all of these bars. So it's 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Now I don't want 5, 4, 3, 2, 1 and 0. So what we're going to do now, as you might have guessed already, is we're going to find 5 and less, and we're going to take that away from 9 and less. So I'm going to put my upper limit as 5. Number of trials again is 15. It's the same as it was. And my probability of success is still 0.45. Again, it's the same as it was. So I'm just going to do that for you now. Upper limit is 5. I get here probability that x is less than or equal to 5 as 0.260759776. So now all we're going to do is to find the probability that x is between 5 and 9 is to subtract them. So subtract less than or equal to 9. Subtract less than or equal to 5. Sorry, from less than or equal to 9. And if we do that, we should get 0.6623 for significant figures. So again, check that, make sure that you do get it. If you have any problems or any issues with having a go at these questions, then do give me a shout, send me an email, drop me a comment. I'm just going to check the page number that we're looking at. So what I would like you to do is be having a look at the questions on page 190. So that's exercise 2.5. The first question, there's no context at all. Then there's a couple of other questions with a little bit of context and things you need to work out. You can also, if you want, have a go at the questions on page 192 if you want a little bit more practice. These are about finding probabilities from the cumulative distribution function tables. However, we don't really need to worry about the tables at the moment. I want you to purely get used to using the calculator and making sure you can use that successfully. So if you want to have a go at that exercise as well, exercise 3.1 on 192, then you can do, but do start on 2.5 on page 190 for me and see if you can get those ones done. Again, like I say, let me know if there are any problems. And as I said at the start, I'm also going to link a video in the description to how-to for this particular distribution function on the CASIO Classwiz, so that you can see one in action if my rudimentary drawings here have not helped. I hope you're staying safe. Catch you next time.